Hello student, welcome to our physics discussion, that is physics in a smart way. In our last lecture, we have discussed on finding the formula of the center of mass. If the masses, this way of dealing with the center of mass is a discrete process. We got the masses, they are just like point masses. I have not got a big bar or big area or big plate or something like that. They are distributed masses. So we are not dealing with mass distributions or continuously distributed masses. This is a discrete system. Discrete. Discrete. There is a mass M1, then nothing else is there. There is another mass M2 here. There is nothing else is there. There is a mass M3. So discrete. But if the mass is continuously distributed, then we got a different approach to the issue. We shall, and we have not discussed that. So we are discussing the discrete mass distribution, and we know if the masses are kept, point masses like masses M1, M2, M3 are kept on x-axis or y-axis. Our formula to find out the central mass will be, our formula to find out the central mass will be xc, or the x coordinate of the central mass will be your, that is sigma mx by sigma m. Upon elaboration, this will be m1 x1, that is a weighted average formula, plus m2 x2 plus the thing goes on, divided by till the last mass is over, till the last mass is covered up, rather. So m1 plus m2 plus m3, the whole series goes on expanding till the last mass is over. Similarly, y coordinate of center of mass, as you know, yc will be equal to sigma m into y, sigma m into y by your sigma m, where the terms, they have got their usual meanings. But now we try to extend. Instead of keeping the masses, or instead of having the masses only on x-axis, y-axis, or z-axis, and we know if the masses are kept on z-axis, a similar formula will be coming in z bar or zc will be equal to sigma mz by your sigma m. If the masses are kept on xy plane, let us say I got a mass m1, which is placed at a position whose x coordinate is x1 and y is y1. So m1 has got a position x1 and y1. I am talking two-dimensionally. You can extend the idea to three dimensions also. To three dimensions also. There is another mass m2 which has got coordinates x2, y2. There is another mass m3, x3, y3, m4 like that. So the xy plane is distributed with the point masses. The masses are kept on xy plane. So now we are increasing our difficulty. So obviously, if the masses are kept like this, the center of mass will be somewhere here, and center of mass will be having its x coordinate, that is xc, and y coordinate, that is yc. Okay, so how to find the xc and yc? In fact, you don't have to find anything. Already you have found out the same formula that is valid. If you want to find out the x coordinate of center of mass, then the formula is sigma m into x by sigma m, m1 x1, m2 x2, m3 x3 plus m4 x4 plus m5 x5 till the last term is over by m1 plus m2 plus m3 like that. Similarly, y coordinate center of mass can be found out by using the formula that you have already discussed, and with a little bit of thought, you can be able to realize it. You can be able to realize it. Think of my picture where M1 has got its weight, that is M1G and all that, because with the help of the weight, we have tried to find out the center of mass. Okay, the idea is not so fault-free, but as I have told you earlier, the basic thing, or the most basic thing is that the thing must be going into our mind. Then we can be able to improvise, then we can able to make it more and more fine. So M1 has got its weight, that is M1G, and similarly M2 will be having M2G. And if you take the torque about the origin, then that torque of M1's weight will be M1G into X1 and all those things. A similar derivation will be coming up, a similar formula will be coming up. So the formula that you have got here, that is central mass X coordinate and Y coordinate, they are valid. Similarly, central mass Z coordinate will be found out. Let us remove this cluttering and make it more clear, make the formula more precise. Okay. We now look at the same diagram with a slight different perspective. With a slightly different perspective. As you know, the masses are there as usual in the coordinate xy space. M1 has got coordinate x1, y1. M2 has got coordinate its position defined by x2, y2. But now, in place of x and y coordinate, we show their positions with the help of position vectors. Position vectors are radius vectors. M1 has got a position vector R1. Obviously, position vector of a point, position vector of a point is usually given by your, that is in terms of its x coordinate and y coordinate, xi cap, yj cap, and zk cap. If z coordinate is available, otherwise it is, in our case, it is xi cap, yj cap, zk cap. I am writing completely. So the position vector, it contains both x and y coordinate. So if the masses are having their position vectors as R1 vector, R2 vector, R3 vector. Similarly, the centroid or center of mass, which has got its x position as xc and y position as yc, must be having a position vector that is rc. And our common sense says rc can be found out if you combine both the formulas. That will be equal to, in the same way that we got m into r by, so to say, sigma m, just like our x and yc, and our common sense says that will be m1 r1 plus m2 r2 plus m3 r3. The series continues till the last mass is over, divided by your, that is 1 plus m2 plus m3 plus m3 plus the series continues till the last mass is over. And we also do know, if I am permitted to remove this thing, we shall be going for something else. There is no limit to the number of extensions you can make to this formula. Since our time in kinematics, we know velocity vector, velocity will be equal to, or is usually, the rate of change of position vector with time. The rate of change of position vector with time. This is a formula we have known long since. Let us consider a dynamical system where the masses M1, M2, M3, they are not at rest, but they are moving. If they are moving, the center of mass also won't be sitting at rest. The center of mass will be moving with the group, as we can normally sense it. So central mass will be having a velocity, central mass will be having a motion, central mass will be having its velocity, central mass will be having its acceleration. So if you take this formula and make the time derivative, then you know this will be giving us BC, or velocity of the center of mass. That is DRC, rate of change of the position vector of center of mass by dt. That will be equal to sigma your m into dr by dt, sorry, dr by dt here by sigma m, that will be equal to sigma m into v by sigma m. Let me make it systematic. The velocity of the center of mass can be found out by using this formula, that is sigma m into v by sigma m. That obviously means that if somebody mass m1 is moving with a velocity v1, velocity is a vector, mind it. Just you don't put the value here and expect to have the answer. Velocity is a vector, must be having its section y component. So m1 v1 vector plus m2 v2 vector plus m3 v3 vector by m1 plus m2 plus m3. And if you consider this velocity formula of the center of mass and again make a differentiation with respect to time, then immediately velocity changes to acceleration. And you can clearly see that our velocity formula of center of mass will be giving rise to acceleration of center of mass. If the masses are accelerating, then obviously we cannot expect our center of mass to be not accelerating. So acceleration of center of mass SC will be equal to the same formula or in the same style, sigma m into a vector by, so to say, sigma m. That means upon elaboration, that is m1 a1 vector plus m2 a2 vector plus, and goes on till the last term is over, m1 plus m2 plus the series goes on till the last term is over. That is the formula to find out the acceleration of center of mass. I don't think we don't need any physical quantity that is related to motion beyond acceleration. Normally, we don't discuss about jerks and all those things, which is rate of change of acceleration. So we have to stop here. So that's all for today. This is a small one, small video. Next class, we'll be talking about usage of center of mass, how center of mass can be used to our benefit or to our profit. Thank you. Next class, we shall